Hello my dear students, let us discuss few more questions, NEET previous year questions in this session. So in last session we have discussed some questions, and now we will be discussing few more questions now. So the first question is here, that is the pKb of dimethylamine and pKa of acetic acid is 3.27 and 4.77 respectively at T Kelvin. The correct option for pH of dimethyl ammonium acetate solution is. So dimethylamine is like this, right? NCH3 CH3 H plus acetic acid CH3 COOH, right? And ammonium acetate, we will be getting ammonium acetate like this, NH4 plus CH3 COO minus, right? So what is the pH of ammonium acetate, he is asking. When pKa and pKb is given, the formula to calculate pH is equals to 7 plus half into pKa minus pKb. So what is pKa? pKb is given first. pKa, pKb is how much? 3.27, right? And pKa is 4.77. So pH is equals to 7 plus half into pKa is 4.77 minus pKb is 3.27, right? So if you solve this equation and do calculation, you will be getting the answer as 7.75. So which is nothing but the option given is option 4. So this formula is very important to calculate pH when you have given with pKa value and pKb value. pH is equals to 7 plus half into pKa minus pKb. This particular question is from which chapter? Chemical equilibrium chapter. This particular question is came from chemical equilibrium chapter, and we will be moving to the next question. That is, the following solutions were prepared by dissolving 10 grams of glucose in 250 ml water. So what he is saying is 10 grams in 250 ml. This is what? Glucose. And next, coming to 10 grams of urea in 250 ml of water. 10 grams of urea in 250 ml of water. Same, 250 ml of water. This is urea. And again 10 grams of sucrose in 250 ml water. Sucrose, this is. So same amount of what is this? Weight and volume is same. So what is the correct relation of their osmotic pressure, he is asking. Pi is equals to ICRT. This is a formula. I is a Van 't Hoff factor. I value for a non-electrolyte. These are non-electrolytes. They cannot be ionized into the ions. As these are non-electrolytes, their I value is equals to 1. So pi is mainly C, R, T. R is a constant, T is also constant. So pi is mainly dependent on C, right? So pi is equals to C is nothing but N by V. N by V means what we can write? V is equals, pi is equals to weight by molecular weight into 1 by, so volume is same, and weight is also same, right? So pi now mainly depends on molecular weight, isn't it or not? Pi is dependent on molecular weight. So what is the relation between pi and molecular weight? Pi is inversely proportional to the molecular weight, right? So the substance whose molecular weight is more, its osmotic pressure is less. So, if you can compare sucrose, glucose and urea, glucose molecular weight is 180. Urea is how much? Urea is 62, I think 60 or 62, and this one is 342, sucrose. So, whose molecular weight is less? Glucose. So that, sorry, not glucose, urea. Urea's molecular weight is less. That is why urea is having more pressure. Urea is having more pressure. That is option 2, like this one. Urea, P2, right? The pressure exerted by, what is this? Glucose is P1. The pressure exerted by urea is P2, and the pressure exerted by sucrose is P3. So, this is least. Sorry, this is highest. Its molecular weight is more, so pressure is high. P2 is high. Then next is P1, molecular weight 180. So, P1. Next highest molecular weight is 342. That is why P3 is sucrose produces lowest what is this? Osmotic pressure. So, P2 is greater than P1 is greater than P3. Option 2 is the correct answer. You got this one? See, one more time I am explaining this. Pi is equals to ICRT, I is same, right? So, pi is equals to CRT, R and T is also same, pi is depending on the C. So, pi is equals to C means what? N by V. Pi is equals to N means what? Weight by molecular weight into 1 by volume. Volume is same and weight is also same, it is given in the question. So, pi's osmotic pressure mainly depends on the molecular weight, that is 1 by molecular weight. What is its relation? Molecular weight increases, osmotic pressure decreases, right. So, you have glucose, urea and sucrose. The pressure exerted by glucose is P1, pressure exerted by urea is P2, sucrose is P3, and molecular weight of glucose is 180, this one is 60, this one is 342. So, molecular weight more means pressure is less, molecular weight less means pressure is more. So, molecular weight is less for urea, urea is having pressure high than glucose P1, than this one that is sucrose, that is P3. So, this will be given in the option 2, right. And next question. For a reaction A to B, enthalpy of reaction is 4.2 joules per mole, right, and enthalpy of activation is 9.6 joule per mole. The correct potential energy for the reaction shown is. So, see, enthalpy of reaction is equals to activation energy of forward reaction minus activation energy of backward reaction. For a reaction, enthalpy of reaction is 4.2 kilojoules per mole and enthalpy of activation is 9.6. Forward reaction is given 9.6, right. So, enthalpy of reaction is minus 4.2 is equals to forward is given how much? 9.6 activation energy, right. If you can calculate activation energy of backward reaction, what will be the answer? Activation energy EA, activation energy EA, backward reaction is equals to how much you will be getting? That is equals to 9.6 plus 4.2. 9.6 plus 4.2, you will be getting the answer if you calculate this 13.8 kilojoules per mole. 13.8 kilojoules per mole. See carefully, activation energy for backward reaction is more than activation energy for forward reaction. Activation energy for forward reaction is 9.6 and backward reaction is 13.8. This you can see in the option 3. See carefully, I am writing here with a black pen now. So, this is the activation energy forward reaction, which is 9.6 here. For backward reaction, the activation energy from here, this is the activation energy of backward reaction, which is 13.8. Okay. And this is an exothermic reaction. Why it is exothermic reaction? Enthalpy of products is less than the enthalpy of reactants, isn't it or not? in this equation enthalpy of products is less than the enthalpy of reactants. Okay, you can see here enthalpy of products B is lesser than A, exothermic reaction, and activation energy of B is more, like backward reaction is more. Okay, this is activation energy of backward reaction. We will be writing this as 13.8 and this one will be 9.6, it is given. Okay, option 3 is the correct answer for this question. And next, coming to the question number 4, the compound which shows metamerism. Generally, metamerism is shown by what kind of compounds? Compounds having bifunctional groups or polyfunctional groups or polyvalent functional groups. Compounds, this is organic chemistry question. Generally, this is from GOC, that too from isomerism. Very, very important, isomerism, you will get at least one question, and some other questions are based on the isomerism. I mean, in some other question, to answer that question, you should also apply the concept of isomerism. So, isomerism direct question you will get, and this concept of isomerism is also useful in the other questions. That is why it is very, very important topic. So, metamerism, in the particular isomerism is metamerism here we are discussing about. The metamerism is a type of isomerism in structural isomerism. Generally, isomerism is two types: structural isomerism, stereoisomerism. Structural isomerism is different types: chain isomerism, positional isomerism, functional group isomerism, metamerism, like that. So, metamerism is compounds having polyvalent functional group. Polyvalent functional group will exhibit metamerism. Polyvalent means the valency of the functional group may be more than one, like oxygen. It can be bonded, the oxygen can be bonded from the both sides, it can form two bonds, right? That is why it is polyvalent, particularly the bivalent functional group. And coming to the sulfur, sulfur is also a bivalent functional group. And next, coming to the carbonyl group is also a bivalent. And next, coming to the carboxylate group is a bivalent. And coming to the carboxylate group is over, right? Amines, NH3, primary amine, secondary amine, all these will show metamerism. So, particularly here they have given a compound like this, C4H10O, C4H10O. So, metamerism is a type of isomerism where the polyvalent functional groups are having different alkyl groups. Their formula will be same, but different alkyl. C4H10O we will see now, CH3, CH2, O, CH2, CH3. Is it C4H10O or not? Yes. This is the one of the isomer of the formula C4H10O. First option I am taking. And second option C, CH3, CH2, CH2, O. So, this is also C4H10O. But you can see here this thing, CH3 here, CH2 here, CH3, CH2 here. But right side what is there here? CH3 only there. Alkyl groups are differently arranged here. Here if you can see the first compound, you will be only having CH3, CH2, but here 3 carbons are there. Alkyl groups attached will be different. Okay. So, the first option is correct answer, and see carefully, but the important thing is this particular compound is ether. In this third option and this fourth option also these are ethers, but this many number of carbons you cannot form a metamer, because see if you can write fourth option CH3O, CH3 you will get. You cannot have a different alkyl groups in the other isomer. You should have 4 carbon atoms. You should have 4 carbon atoms to exhibit metamerism. You should have 4 carbon atoms to exhibit metamerism. So, option 1 is the correct option. And next one is 5th question. The major product of the following chemical reaction. This question is from again alkyl halides organic chemistry, second year. Alkyl halides, first chapter in organic chemistry. This is addition reaction. Addition of unsymmetrical reagent. Unsymmetrical reagent to unsymmetrical alkene to unsymmetrical alkene, right. So, this is an unsymmetrical alkene and HBr is a unsymmetrical reagent, right. HBr is unsymmetrical reagent. And one more important thing is in presence of peroxide, this is the very important thing here. In presence of peroxide, follows what rule? Follows anti-Markovnikov rule. In the absence of peroxide follows Markovnikov, but in presence of peroxide follows anti-Markovnikov rule. It follows anti-Markovnikov. So, what is the anti-Markovnikov rule? Means in the reagent generally you will be having two parts, one is positive part, other one is negative part. In HBr the positive part is H plus, negative part is Br minus. According to anti-Markovnikov rule, the negative part of the reagent will be added to the carbon having more number of hydrogens. Carbon having more, not less. The negative part of the hydrogen, the negative part of the reagent is added to the carbon having more number of hydrogens. See, in this compound between CH and CH2, bond is broken down, a double bond is broken down. Here anti-Markovnikov rule, the negative part means Br. Br will be added to the carbon having more number of hydrogens. Here this carbon is having 2 hydrogens and this carbon is having 1 hydrogen. So, negative part will be added to the carbon having more number of hydrogens Br here, and positive part H will be added to the carbon having less number of hydrogens. You have to check only with the doubly bonded carbon atoms. Break the double bond, add H one place, Br one place. According to anti-Markovnikov rule, Br to the carbon having more number of hydrogens, H to the carbon having less number of hydrogens. See the option here, which of these following is the correct one? It can be option 2. In the option 2, Br is added on this first carbon, H is added on the second carbon. That is the correct, because Br negative part is added to the more number of carbon having more number of hydrogens, right. This is a very, very important question you will get very regularly. And Markovnikov, anti-Markovnikov is very, very important. And anti-Markovnikov rule or peroxide rule, anti-Markovnikov product is formed only with the HBr. This will not works out with HCl. If it is HCl, for example, Cl will be added to the carbon having less number of hydrogens. Okay, that is the important thing. Anti-Markovnikov rule is working only with the HBr only. It will not work with HCl, HI, right. Okay. And next, which of the following reaction is the metal displacement reaction? Choose the right option. So, first option, second option, first option and second option are decomposition reactions, not displacement reactions. First option and second option are decomposition reactions, because PbNO3 is decomposed to PbO, NO2, NO2, KClO3 decomposed to KCl and O2. Decomposition. So, second and third reactions are displacement reaction, but third option particularly metal is displaced. Here is chromium is displaced with aluminum. Chromium is the metal which is displaced with aluminum. So, third option is correct particularly. Third option is a metal displacement reaction. This particular topic, this particular question is from the redox reaction. Redox reaction also you have got one question. And this is a very simple question, but you may have sometimes some tricky questions, but this is simple question that you have got in the 2023 NEET examination. Aspirin and paracetamol belong to the class of narcotic analgesics. Statement 1. Statement 1 2 type questions. Statement 2 is morphine and heroin are non-narcotic analgesics. In the light of the above statements, choose the correct answer from the given below. So, which lesson it is? Which chapter? This is chemistry in everyday life. So, aspirin and paracetamols are analgesics. What do you mean by the analgesic? What do you mean by the analgesic? Analgesic means it reduces the pain. But these are not narcotic analgesics. These are not narcotic. This is non-narcotic analgesic. Non-narcotic analgesics What is the difference between narcotic and non-narcotic analgesics means? I will write here narcotic analgesic, non-narcotic analgesics. Both will reduce pain, but narcotic analgesics are addictive. You can get addicted to it. But non-narcotic analgesics are non-addictive. So they have given wrong options, wrong statements. All these are wrong statements. First one is non-narcotic, second one is narcotic, second statement. Means what? Morphine and heroin are narcotic. Both statement 1 and statement 2 are false. They have given vice versa. Okay. And next question. Ethylene diamine tetraacetate. Question is from complex compound. This chapter is very, very important. Complex compounds is very important because you may get 2 to 3 questions from this. So, EDTA, tridentate ligand with 3 nitrogen donor atoms, hexadentate ligand with oxygen nitrogen donor atoms, unidentate ligand, bidentate ligand with 2 nitrogen atoms. See, we can write its structure so that we can able to understand what actually it is. Okay. Ethylene diamine, CH2, ethylene diamine, here nitrogen and here nitrogen, tetraacetate, right? Tetraacetate means I will be writing CH3COO minus and CH3COO minus, CH3COO minus, CH3COO minus, and on nitrogen lone pair here, on nitrogen lone pair here. So, what he is asking is ethylene diamine is what dentate? It is a hexadentate ligand. Why it is an hexadentate ligand means, here this is one donor atom, second donor atom, negative charges will be working as donor atoms, 3 donor atoms, 4 donor atoms, and lone pair, 5 and 6 donor atoms there. Out of 2 donor atoms are nitrogens and 4 donor atoms are oxygens. So, it is a hexadentate ligand with 2 oxygens, 4 oxygens, yes, with 4 oxygens and 2 nitrogens. It is a hexadentate ligand with 4 oxygens and 2 nitrogens, right? We can see 4 oxygens donating electron pair and 2 nitrogens donating a. Hexadentate means total denticity is how much? Hexadentate. Total denticity is 6, right? 4 plus 2, 4 oxygens, 2. So, the correct option is option 2, right? And next, coming to the identify the compound that will react with Hinsberg reagent to give a solid which will dissolve in alkali. So, generally which will dissolve in alkali, right? So primary amine reacts with Hinsberg reagent like this, that is Cl S double bond O, benzene sulfonyl chloride. Here it will be H and H, NH2, right? So, it will react with it and forms RNH S double bond O, benzene, and because of this H, it reacts with NaOH base, primary. But secondary, if you can take, secondary means it will be like something, nitrogen, hydrogen here, chlorine, S double bond O, benzene sulfonyl. Hinsberg reagent is benzene sulfonyl. So, the product you will be getting is R N S double bond O and benzene. So, you do not have NH here. So, it will not react with NaOH alkali. The amine that will react with Hinsberg reagent and dissolves in alkali is primary amine. You search for primary amine here. This is a tertiary amine, first one. First one is a tertiary amine. Second one is not amine. Third one is, fourth one you see primary amine. Fourth one is the primary. Third one is the secondary amine. Fourth one is the primary amine. So, fourth one is the correct answer. Dihedral angle between least stable conformation of ethane. Least stable conformation of ethane is what? Eclipsed conformation is least stable, right? Eclipsed means first carbon, second carbon, hydrogen, 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 and hydrogen backside. One second, I will hydrogen exactly backside, hydrogen exactly backside, hydrogen. The dihedral angle between two carbon, angle between the hydrogens of two carbons here will be 0 degrees. It is eclipsed one on the other. Okay, so the correct option is least stable conformation is eclipsed. So the angle is 0 degrees. Okay, next 11th question. An organic compound carbon is 78%, hydrogen is an organic compound carbon is 78%, hydrogen is how much it is given? Remaining percentage is hydrogen. Hydrogen will be 22, right? Yes, 22. So what is its empirical formula is asking. First of all, you have to find out atomic ratio. We will be getting atomic ratio 78 by atomic weight by atomic weight, weight by atomic weight. Yes, 78 by 12, it will be 78 by 12, it will be what? 6.5, right? And 12 by 1 is 22. Okay, so this is atomic ratio. From atomic ratio, carbon atomic ratio is 65, hydrogen atomic ratio is 22. You have to find out simplest whole number. Simplest whole number, how can you find out simplest whole number? 6.5. 6.5 by 6.5 will divide with same number, 22 by 6.5. This will be getting 1 and this will be getting 3.3. This we will be taking 3. Simplest number of carbons are 1 and hydrogen is 3. So option 4 is the correct answer. So first one is COHCl. You will be getting here benzene COHCl, benzaldehyde you will get. This is called as Gattermann reaction. Means 1 is there for 2. Option 1, A option is there with 2. And the second one is NaOH. This is haloform reaction. Haloform reaction 2 with 3. Third one is esterification, formation of ester. Fourth one is 𝗪𝗏𝗪𝗏𝗪𝗏𝗪𝗏𝗪𝗏 reaction. So the correct option for this is 1, 2, 1, 2, 2, 3. 1, 2, 2, 3, 3, 4. Yes, first option is the correct one. First option is the correct one. These are named reactions. All these are named reactions. So this is the 12th question. We have finished 12th question. In this session we have finished 12 questions. In the next session we are going to continue with 12 more questions. Thank you very much.